Hey everyone, welcome to your design computing tutorial for this week. My name's Sam and I'll be taking you through the content for this week. This week's topic is breaking out of the canvas. So what does that mean? Well, this week we're looking at going from outside of your sketch to the world beyond. That is, could be as simple as your eye pushing a button to make something happen in your sketch, maybe typing in some text, but it could even go as far as video being streamed into your sketch and doing something intelligent with that, or audio for that matter. Hypothetically, you could also expand this to other sensors and the likes, but that's not something we're going to cover in this week's topic. And let's get into it. So, what is the DOM, you ask? What are we talking about? The DOM, DOM, stands for the Document Object Model. Why is that relevant at all to us? Well, that's the format, the model, if you will, the representation of how a browser stores all the different pieces of a web page. So, for example, here in this image, you can see that up the top over here is the document. That's the entire transaction, just the entire HTML web page. Then there's the actual HTML code. So that, if you remember from our tutorials on objects, this is an object, and it has an array of objects that live underneath it. So, for example, one of the objects is the head. It's for storing things that are considered metadata about the page, not necessarily features of the page you see. So, for example, this could hold the title element with another object, my title. This would be the little tag that you'd see across the top of a web page. That's how you define it. That's where it lives within the web page itself, within the document object model. Now, if we go to another element of this array, then we can find the body. Now, this is where things like our P5.js sketches live themselves, which, in an ironic pun that some of you may have already picked up on this week's topic title, P5.js sketches are drawn to a canvas element in the document object model. So, for example, other things that you might find in the document object model would be things like a header, which could contain text like my title, or P5 DOM and getting user input could also be another heading. Other things you might find are links, like hyperlinks. You can have formatting things like paragraphs, and other things for grouping elements together like divs, which we will cover actually in this week's lesson. That being said, HTML, if you haven't dealt with it before, you don't need to know about it for this course. That's a later subject. What we're going to be learning today is about how to use a couple of these elements outside of our P5.js sketches that are already built for us so that we can get input from users for our sketches to do interactive behaviors. So let's have a look at the first task. In this task, we're going to create a sketch which counts the number of clicks on the button. Let's jump across the tutorial page and dig into this a little deeper. Okay. You've probably potentially already read through the blurb at the top. We've kind of explained a lot of this stuff, but just to double back in terms of P5 DOM routines, there are functions, routines that are part of P5.js that allow us to create elements within that document object model that we can then use to get input into our sketches. So, for example, one of those functions is this create button function right here. Click me, which, if you remember from the picture of our sketch, there's the button there saying click me. Let's dig into this a little bit deeper now. Starting at the top of the sketch, we have global variable for counting the number of clicks. As you can guess, that's what's showing us the number of clicks up there. And what's rendered there. Ooh, apparently this early version, I left off a few semicolons. JavaScript will be fine with that, but we'll make the editor happy just for now. Then we jump into our setup function, typical create canvas. Like I said, we're creating a button object. We're saving that into our variables. This gives us a container, a reference to the button object that we can see in the middle of the screen there. Now, as I was saying, it allows us to manipulate elements of the DOM. So in this case, we are calling the position method and passing in 150, 150. This is just like any other normal P5 element where we're just sending an X and a Y position to the button. Next, we're calling the size method 100, 100. Once again, it's an X and a Y size, and that's changing the dimensions of the button. Now last, we have something a little bit more interesting, a little bit more exciting. We have this mouse pressed method, and we're passing update count. Now I've tried to leave a hint here to help you out here in the comments. Pass a function by reference, which will be called when the button is pressed. So, you've usually been working with functions where you have parentheses afterwards. This is calling the function, executing the function. But you can also, the function still exists as a variable. And if you want to pass the function to something else without calling it, but just being like, cool, here's something you can use later, then you can pass it by reference, which is leaving off the parentheses. So this is a technique called a callback, if you want to get technical on that. Now, update count. Where is this defined? Well, it's a function, so it could be technically anywhere in our code. Normally, I would move this further up the top of the code if I was writing it, but p5.js, you often end up with set up in the drawer to be the main focus of the sketch. So I've placed it down the bottom. It's really a stylistic choice. You can go either way. Let's jump down to it now. So update count is this little function over here, function update count, click count plus plus, that's a global variable up there. And quite simply, whenever the button is pressed, because we've set it in the mouse pressed function method, then every time the button is pressed, we increment the click count variable, and the state of the sketch is changed. So we jump over to our draw loop, and we have a look, and it's very simple text that's drawn there. Click count is rendered to the screen, just like we saw over here. So that's about it. But you might have noticed that we're not doing anything to do with drawing the button in our draw loop. And that's a bit different from the other p5.js stuff we've been working with. So because this is dealing with the document object model, we're dealing with something in the browser, not within the processing canvas itself. The browser is responsible for drawing it, and we just tell the browser, hey, create a button. And the button's like, the browser is like, yeah, cool, I've got that. And it just keeps that around and keeps that up to date for us. So this technically is being drawn on top of our P5 canvas. You don't have to dive too much into that, but just to, this is roughly what's going on. Dealt with HTML and layouts before, you're probably all over this, but otherwise you can look forward to some future subjects. Okay, now that you've got a general idea of what's going on here, have some fun with it. Try out the suggested task here. Try adding some color to this sketch. Try putting a shape in that moves around the screen whenever you click the button. Have fun. And we're back. I hope you guys had some fun putting another interactive element into the sketch. I'm just going to go and work through a quick demonstration of me doing something along those lines. And there are plenty of other ways to go about this. I'm just going to go with the first that comes to mind for me today. So we're putting a square in the canvas. I'm going to make it move around as we're talking about. I'm just going to skip over the color because you guys know that part pretty well, and got a bit of a monotone theme going on in today's tutorial for better or worse. So first of all, drawing a rectangle. We'll start by drawing it at 0, 0, and we'll just go for 50, 50 for a square. Test this out, click run. Great, you can see the rectangle up the top. Then what we're going to need is we're going to need some state. So we're going to need to be able to have some state that exists across multiple draw loops. So in this case, let's make the position variable, so square x, and we'll have square y as well. Great. And we'll drop those in over there. So now instead of having the 0, 0, we're having the variables, nothing changing them at the moment, but let's add that in. So jumping down here to update callback, it's being passed to the mouse press function. Let's add some changes over here. So in this case, for very simple behavior, we can add in random. In this case, we want the width of the sketch, and let's copy that out. For square y, I'm going to have the height. I think I misspelled that. Let's find out. Oh no, we're all good. Cool. So as you can see, we've got a little bit of odd behavior because the corner of the square is just hanging in the corner there, and sometimes we lose it. You'll also notice that, for example, it can end up going behind the button, which, to be honest, works in our favor in this sketch probably, but it is a little bit odd, and it does show how the button is being drawn on top of our canvas. So it's just something to be aware of. You kind of lose a bit of control over some of these aspects of the sketch when you're using the P5 DOM objects. Great. Hopefully you guys have gotten that in. Hopefully you guys have understood all that, and let's move on to the second example, which looks something like this. So there's a text box and a slider. Obviously we'll demonstrate the interactive aspects of this when we run it. And for this task, once you feel like you've gotten your head around it, try adding another shape, maybe another rectangle, ellipse for variety, and try and change the size of that with the slider. Let's have a quick walk through the example and have a bit, and you can see how this will probably work. So, like I said, interactive behaviors that we have here. Amazingly, we have this text box that we can type stuff in and gets drawn on our sketch. So we can say, yay, very enthusiastically. And then we can change the size of the text from microscopic to, I don't know, 60 points, something like that. Probably depends on your font. Pretty straightforward, but what this gives you is a tool where you can get a user to actually put some text in and do something interesting with that. How does this work? Well, once again, we have some global variables for keeping the state. In this case, we have something for holding a reference to the text input, the text box right there. And we have another variable for holding a reference to a slider, this slider bar that's right there. So usual create canvas in the setup function, then we assign to our text input function. So we go create input. This is the default text that you see in the box there. That's how it gets placed in there. And text is saying this is a text box. There are a couple of other varieties of things like color pickers that you can place in there and use for other forms of input. Numbers as well is another useful one. And this column here simply tells the browser what kind of form element to give to you as to display to the user. Moving along, once again we're using position and size methods. These are exactly the same as the other DOM element, the button we were using before. All the DOM elements have a unified API, as we call it, or which allows you to even though one thing's a text button and one thing's a button, one thing's a text input, they all have similar properties that you can manipulate through functions such as position and size. So we position the elements, that's how we get them into the middle there. And if we jump over to the slider input, or create slider, in this case it takes 3 arguments, the start of the range, the end of the range, and where the slider will begin, which is how the slider begins, how the bar begins in the middle. Once again, we position the element, all pretty straightforward. Now, these elements, you can connect them up to events. We're not going to cover that right in this tutorial, but the events don't necessarily in and of themselves give you the value. So what you need to call instead is the value method. So in this case, in our draw function, we are simply drawing whatever's in the value method or returned by the value method as the text size, this is for the slider, and for the text input, we just grab the value, which in this case is the text that's there. And so every time the draw loop runs, it checks to see what that value is every time so therefore, when you're typing something in, every time the draw loop runs, the sketch will be updated with the new value of the input. So I'm going to leave you guys with that for a moment. Have a bit of fun playing around with change the size or position with sliders. You can even try moving around the UI elements, try and make a bit of space for things if you want. But we'll check back in a moment. And we're back. Hopefully you guys are able to solve that rather quickly. Once again, just to give a quick demo of how to get this together, I'm just going to use the same slider that's there. So in this case, once again, we'll create a rectangle and we'll draw this at, actually let's use this for the X and the Y values, and we'll make 50, 50 once again, and finish that off. And because the range of the slider is 1 to 45, I'm going to multiply that by 9 to roughly equal the size of the sketch. Just for demonstration purposes, sure enough, as we move this, the box moves across on that line. Great. Hopefully you guys were able to solve that one pretty easily. Hopefully you had some fun doing some other behaviors with it. Moving on then, let's have a look at the third example. So the third example, and this uses both a button and a text box and mimics the behavior of typing some text in and pressing submit, or sending a message, whatever that kind of behavior you've definitely seen before. And this sketch then displays the messages that are being typed up on the screen. Pretty straightforward. Let's have a look at the code. So the state that we keep is the text input. Like in the previous sketch where we were pulling the value from it, we need to be able to access the text input at other points in our program rather than just the setup to access the value. So we're going to declare that as a global value. The messages that are going to be drawn on the screen are going to be put in an array, so we'll just get that ready to go up there. So setup. This one's going to get a little bit more complicated because we've also grouped together a number of our elements into what's in HTML is a div. And it's a kind of like the concept of a canvas. So with a p5.js canvas, 0, 0 is up in that corner. In the same way, when you're in a browser window, 0, 0 would hypothetically be up in that corner. But when we create a div and put elements inside the div, so if we remember back to our DOM idea, there was objects, they had an array of elements that lived underneath them. So if we say that these elements live inside this div, are children of this div, then their 0, 0 becomes this top corner up here. So we can define the position of this message in regards to the 0, 0 there, and the box, and the submit. And elements in a web page can also push other elements further down the page, just like you're working with a Word document and you insert a picture in the text. So, jumping back, let's have a look. We have this div that we're talking about right there. We use the p5.dom create div, and we pass this to controls. So making a group of controls. Then we create the label, enter a message and press submit. That's the message we see here. And then we create the text input. It's an empty field. We have the instruction up there, so we can skip over putting anything there. If we, with that, we don't have to. Once again, we said it's input of type text. And then we change the size of the input. So we're making it longer here with the 250. Following that, we have the submit button that we create. And we add in a submit message callback, which we'll have a look at in a moment after we work to the setup function. And then, once again, we go back to the controls. So we've got this group of controls, and we go child label. So label is now, this label up here is now a child of the controls. It lives inside this control block here. Then we have text input, also add that in there, and the submit button. So the label goes on top, just like we're saying, like a Word document, then the form goes on, then the text input goes underneath that, and the submit button goes underneath that. As an aside, the paragraph here, the create P, that has a behavior in a HTML document where it puts everything to the next line after the content. And that is why the text input and the submit input get pushed down. After this, we can position the controls as an entire group. So we can just position this 30 in from the side, 300 down, and the rest of the controls, all the paragraph, the form, and the form elements, they get moved as part of this div. So you can see why if you're building more complex behaviors, by grouping them together, you can move them around and keep the elements that you need to manipulate the control all in one place. It makes it a lot saner when you're dealing with these items. Now down here for the controls, we're using the style method. This is a way of accessing what's called CSS, which is a language which is used for creating style sheets and styling web pages. Very important, used on nearly every web page these days, and it is a topic for another class. So if you know about it, feel free to play around with it, but don't feel like you need to, you should already know about it right now. Now, I mentioned the submit message callback. Let's go have a look at how that works. So down here, once again, we have a callback defined, and let's have a look at what we do. So messages, that is declared in our global scope up here, messages equals array, and we're pushing onto that. So we're adding a value to the end of the array, and we're adding the value of the text input. So every time you hit submit, this function gets called, and we add the content of the text input to the array of messages. Then, following that, we clear the text input by passing a value to the value method this time, rather than leaving it with no value or an empty value, and we pass an empty string to clear it. This way you get the feeling that something's happened with the UI when you press the button. And you should also, as we can see in the draw loop, you'll be able to see the text appear. So over here with the draw loop, we have background being set, then we have a nice little for loop here, which iterates through the messages, drawing them as text, and moving each message of text down a line every time for every message. So obviously here, if you get too many messages, they're going to start going off the bottom of the sketch. That's something you can toy around with your own time fixing if you want. But otherwise, have a play around with this idea of a div and grouping controls. Try moving the tile yourself, and potentially try adding another control to it. Have fun with that. I'll be back in a moment. Welcome back. Hopefully that didn't pose too much of a challenge for you. So just in case you hadn't worked it out, remember that manipulating the line 30, the position method of the controls, is how to move it around. And hopefully you guys, if you wanted to dive into it, worked out how to add in another form element. That being said, the next challenge is going to push these skills a little bit more, give you a bit more of a open playground to try this out with. So we'll talk about the next challenge in more detail, and we'll skip over running through this one. So in the next challenge, we have a sketch. Now this sketch has some very basic text generation in the sketch, and your job is to put together a UI for it. Something that will allow a user to put in their own text. Let's have a look at the code. So if we jump in over here, we have a global that's holding the scope of our text generator. Then we have a setup function, which in this case uses the build linked text method or function to create a text generator from the string. Testing 1, 2, 3 for the win with an exclamation mark. And then is setting a text size just so that's ready to go for our draw loops. Feel free to move that if that helps you for your project. Then we hit the draw function, and we have a control here to say only redraw this once every 60 frames. Now, the reason why this is here is because if we're interacting with input from outside the sketch, we may want to update the draw loop if there's user input inside of that 60-second window. So if we tried to change the frame rate of the draw loop, we might actually interrupt the responsiveness of our program. So in this case, we are running the draw loop 60 times a second, but we're only changing the content every 60 seconds. And so you can see here the background is being redrawn inside this control. So it's only overriding the previous layer, only removing the previous layer every 60 frames. So moving on from there, after this we have a nice little for loop. So it's drawing things and pushing them off the side of the canvas a bit just to fill it out. And it's driving text drawing here. So the text is the letter from the text generator. So the text generator has a letter property that we can pull and grab the letter. And then over here, we have just some modulo to move letters along each step for the iteration. And we have a rounded division, so that creates a step. So every you could use other functions here such as floor or seal, but you guys have mainly dealt with rounding, so we'll stick with that. So what this does is creates a step of numbers, and this way we don't have to have multiple levels of for loop, and we can still get out the tile of letters. Then for each iteration of the for loop, we move the text generator to the next letter by picking the next letter, which, although we've got this input string, we can see that we do get other words like wing popping up in here, ting, and other faux, other words that don't appear in the input string, but are derived from the patterns that exist in there. So call pick next, add that next element to replace the text generator, run it again, we draw the letter from that, we pick the next one, draw the letter, pick the next one, draw the letter, pick the next one. Okay. So this is enough that you can dive in and you can put in your own user interface. So you want a user interface that allows you to change what the text generator is pointing to by using the build linked text. So the value from a text input will have to go in here. You'll have to move this into a control structure in your draw loop, and you'll need a way to control when that gets called. So it could just be that it refreshes every time there's a change in the text box, which I'll leave you to have some fun detecting that. Or you could also use the submit method that we had before. And so you could set up that code in your setup function, link in a callback, and update the content of the text generator whenever the user presses submit. So I'll leave it up for your creative expertise. And when we come back, we can have a look at how we might add that in as well as have a look at how the text generation works as a bit of an extra bonus piece of content if you have time. So, task number 4, have fun. And welcome back, everybody. Hopefully you guys had some good progress putting together a UI for our little generative sketch. Let's dive in and have a look at how I was thinking about going about adding in a UI. Okay, so as we were saying before we took a break, we need to get some new text into the build link text function so that we can create a new text generator. Now, really, we want to just have a repeat of the UI we had over here, where we can type in something, hit submit, and get something to happen. So in this case, let's just go and grab, let's just cheat, and well, it's not cheating. Let's be smart about this. Let's reuse this code that we had already over here. So we'll grab the control box that we were talking about, the box of controls, and let's drop that into our setup function. And yep, all good. And so what we're going to need is we're going to need this text input. So before in the other example, we had text input as a global, and let's just put it on a new line so that we can drop in a quick comment of global for storing a reference to the text input field. Great. So this has already been set up down the bottom here to create the text input, create input over here. We've got a submit button, which is created in line of the setup function. We don't need to access that outside of it. But the submit button is going to need the submit message. We're going to change this to submit text. So we're going to change the name of the callback function to submit text. So this is the function that's going to be called when the button is pressed. And so we are going to scroll down below our draw loop and above the text generator code, we're going to create a function and submit text. It doesn't take any arguments, and close the brackets. And we're just going to drop in a comment for it, callback for handling the update to text generator when submit is pressed. Or we could probably change that to click. You may be useful, it may work with touch interfaces, but I haven't tested that. You guys can play around with that one. Great, so we've got submit text over here. Now, we're gonna need to grab the we're gonna need to grab the text generator. In fact, let's just grab this whole line here, and we're gonna drop this into submit text. Now, we want to go and have a look at the submit function over here, and we want to grab the text input dot value that we had there, and we want to replace the argument that we were passing in the literal argument. Now we're going to replace. Now we're just going to build the text off what is in the text input, and then we're going to also clear the text input. I'm going to leave it there. Maybe oftentimes when you're messing around with things like this, doing more work early is not always a great idea. Oftentimes you're better off just doing the simple thing first, seeing how it goes, and then deciding, does it feel strange that the text stays there? Perhaps you might actually want to have a clear button for the user as well as a submit. Quite possibly the user doesn't want their text being deleted every time they hit submit. That could become annoying. So we're not going to do that at first. We're going to see how it works to begin with. Great. So back to our final little sketch here. So we're going to grab the value from text input whenever the generator is, whenever there's value in the text box. So let's hit run, see whether we've got any issues. Okay, cool. So we've got our text box there. It is sitting over the top of our UI. We could move that down lower. I'm not going to worry about moving it right now. Now, let's see what happens when I press test. Okay, so that changes. That's all right. And we could go, we could change it to the test. Get a little bit more complicated. Underscores looping in through there. So that's working pretty well. It's a straightforward thing. Now, I'm just going to cover one extra thing that we could do. I mentioned previously that when dealing with input coming from outside, we might want to update our sketch. I'm just going to make a tweak to the sketch so that we can see this more easily by looking in the draw loop. And we're going to change this to update every 200 and let's go every 240 frames. So once every 4 seconds. So it takes a little while. Now we see this. And so when we put in test, just wait for it to change, hit submit. We're still waiting a while for the things to change. We're waiting too long. That doesn't feel like something happened when I press the submit button. The UI doesn't feel right. So let's fix this up. So there are a couple of different strategies we could use for this, but remember that in the draw loop, we have this if frame count equals 240, the thing we just added to. So what if we used an or here? So we create a second condition where it may update. So we're going to say or redraw. We're just going to call it redraw for now, or redraw. And in some languages you use the literal word or. Obviously, as you know, in JavaScript we use the double pipe for the or. Great, so this is variable redraw. Now this is going to be a Boolean value. Let redraw equal true. So it'll be true or false. We're going to start with true, and you'll see why when we hit run. And just have this. We're going to call this a switch. So switch for triggering an early redraw of the text. And so when we scroll down back to our draw loop, so we've added this, and like we said, it's a switch. So we want it to be on, and then we want it to be off. Otherwise we'd redraw every frame. So let's drop this in, redraw equals false. So whenever the draw loop runs, it'll turn, whenever the text's drawn, it will disable the redraw. So let's run, and as you can see, we can see the text immediately. Now we still haven't fixed the issue where when we hit submit, it can take a while for that to fix. By putting the switch here, now in our, going a bit too far, now in our submit text function, we can set redraw to true. So trigger early redraw. And so when we hit run and we type in test, immediately it changes. And see, every time I press this now, we get a new generation of the text. Yet when we leave it alone, it's only every 4 seconds. So this, by adding in that switch, we can have our usual draw operations, but when we get user input, we can jump in, grab that input, update everything, and make sure that the interface feels nice and responsive for the user. Great. So hopefully that has helped you guys with all the UI things. Gonna just quickly talk about some of the other examples you can have a look at in this week's content. And then if you are interested, we can talk a little bit about the text generator function that was used in this example. So we'll skip over this one and go straight to this slide. So what about other forms of input? We talked about at the start, you can grab video or audio input. There is a pretty good example there on the CCC's page that'll show you how to grab a webcam input with p5.js and do things like grabbing images from it or colors. This doesn't go as far as machine learning. There are libraries, though, on the p5.js website. If you go there, there's a section called libraries. If you're interested in that, you can look at the .gui example. It talks about getting a library called .gui that also does user input things like sliders, faders, dials, and to be honest, probably looks a little bit better than some of the UI elements we were using today. If you don't use CSS, it's pretty stock standard. So you guys can go and have a look at that. There's also other algorithms that exist on there for different mathematical operations, arithmetic. There's collision libraries, all sorts of other stuff that you can dig into on there. You can just have a look at the .gui example if you're interested to see how that feels to work with. But more or less, it's grabbing work that somebody else has done, and in a similar way to how we use the text generator, there are a couple of functions that you can call, and it makes the code, and you get to use the code that somebody else has written, and if it's already solved the problems that you would encounter if you were trying to write some of this stuff. So that can be really useful, really powerful. And additionally, there are some other sound libraries that exist on the p5.js website. There is an example of using a sound library to get some microphone input in this week's content. That's using the core p5.js library, which particularly for microphone stuff is not very well supported cross-browser. So your mileage may vary with that one. But on the P5 website, there are some fun examples of different synthesizers and things like that you can build with it, and they do work across a lot of browsers. And there are other libraries that also work in other browsers and give you a lot of other fun tools to work with there. Great. So if this is the main tutorial content for this week, feel free to go and check out the other stuff. Otherwise, stick around and let's have a talk about what's going on in the text generation side of things. Okay, new camera, yellow, bright, and batteries. Let's dive into the extension topic, talking a little bit about how the text generation worked in the last example. We'll come back to this diagram in more detail. Let's go back to the code and work through that first. So underneath the text generator tag, we have the class declaration. Now this is using the old class declaration syntax with functions. I did that so that the class declaration could exist underneath the draw loop and the setup function. I've quickly changed it up in VS Code here. This is what it would actually look like in more contemporary JavaScript. So the class text link has a constructor that accepts the argument letter. It assigns the letter property. You're going to be using that in the example. And there's also transitions array. And so this is holding a link to every letter. And this is this description over here that we've got. We've got var letter. In this case, just put an A there, just kind of give you a hint what micro there. And we've got the transitions. So each of these nodes over here is an object. It's a text-like object. This here, whoops, don't click on the slides. They change on you. This here is, for example, the letter property that might be in there. So you have the underscore, if we had, if the input was the test, we've got a letter that's T, we've got a letter that's H, we've got a letter that's E for the, and then we have a letter of the underscore, and we have the letter of the S for the rest of test. Great. So that's all pretty easy to follow. What's this whole transitions business? Well, just like in the DOM that we've been talking about in this class, each of these objects has an array of objects that it references or talks to. And so that's what the meaning of these arrows over here. So T can move to H, and that's shown on the diagram over here, and H can move to E over here. Now, E can move to S, but just like in test, and it can also move to underscore. So it has two options. So it would have two text links in its array. Great. So that's kind of simple. How is this different to the DOM? Now, typically, in a web browser, the DOM only allows for children to go down down the tree. They can only link to more and more children. In this case, this structure is cyclic. You can move around the structure in different and the cool thing, the reason why it becomes fun for generative purposes, is because you can move around in different paths. So let's have a quick look at the pick next function. So the pick next function over here has a length. So it grabs the... Oh, it actually doesn't need a length. That was from the previous version of that. We can just get rid of this entirely. So pick next function, what does it do? Returns a random value from the transitions array. Pretty straightforward, right? Now, so it can go to T, so from T, it can go to H, it can go up to E, or it can go and technically loop back on itself, which we'll see in a moment, because there's a T there, there's a T there, and to make sure that you can always traverse or always have a cycle in the structure, when it builds these lists, it always links back from the end to the start. That's a bit of a minor detail. So if we were to roll a die, is it an E versus a H or a T where it goes? We've got three different options, and those three options represent the possibilities that are encoded in this text. So it models the behaviors of this text in a very naive and simple way. Now, this style of random structure you might hear referred to as a Markov model, where it's learning from some input and it's building a probabilistic prediction of what that content might be. Now, this would be a very naive Markov model. It's only going from one letter to the next. Markov models, as used in our research, are typically considered much longer strings of text for predicting what comes next. So, for example, ideally you'd be thinking about words, so what word is likely to come after the, and then you might think, well, what words are likely to come after the test? Hopefully you've got enough input for that. But, for example, you can get an idea of how this works. So, when we were dealing with the longer text like testing for the win, for example, there are more and more paths there, more and more times where you might have multiple possible links to the same letter. And let's jump back to it, and let's have a look at build link text, because that will tell us a little bit more about how we make sure we get the distribution correct across all these letters. So when you call build text, you pass in the text. It then does a little bit of work ahead of time. So it sets up a map, which is like an array, but for saying, while an array is a list of things that's all together, maps are for things that are split apart. They don't really have an order. So for example, things like when we've got text coming in, yes, there's an order that we could say the letters go in the alphabet, but we don't know what order they're going to appear. So we might say, so for example, we're going to say T is going to relate to the text link T object later on. We'll see that. So that's going to map from T to the text link object. And it can create a whole big table of T maps to this one, H maps to this one, E maps to the other. You don't necessarily need to understand maps at this stage, but it's the most effective tool for this algorithm, so that's what I decided to use. Then we have last link. So this is going to be used in our loop down below to keep ratcheting forward what the current text link is. Then we have text head. So as I mentioned before, the end of the string links to the start of the string to make sure that we can actually loop around and don't run out of text to generate. We don't reach dead end in the cycle, because then we'd get an undefined value and the whole sketch would blow up, and nobody wants that. So let's move into the iteration. we have the text variable. We're calling the split method on it, which you can place a character as an argument for the split method. This is a method for strings in JavaScript. And it will split apart the string into an array based on that character. If you don't put anything there, it just gives you all the characters as individual elements of an array, which is exactly what we want. So you could say that off into an array and then write your for loop. I was having fun with this, so I used the for each iterator, which is very similar to a for loop, but it calls a function that you pass to it as the argument for each individual element. So for each element, it's going to call our function, and our function accepts the argument of char. So this is a way that you can declare inline functions or anonymous functions, depending which parlance you want to use. So these are functions that you can declare without actually giving them a name, effectively. And so then for each letter, we set up the current link. And so this block of code here is to establish what that current link is. So if the character does not exist, so if the character map doesn't have a character for this, or a link for this yet, then we're going to create a new text link with that character, and we're going to set the map. So we're going to set this character relates to this the text link object. But in the case that does exist, then we just ask the map, can I please have the text link object? So we've established what the current link is. Then we move on to last link, which is the link that we've just established. We then add onto its transitions the current link. So the link we've just set up, or we've retrieved, we push that onto the last link. So in this case, if the first one was T, when we get to H, we'll say, cool, we don't have a H yet, create a new text link, and now push that onto T's transitions. And in the next line, then we say, and now H is the last link, and we do it again. So H will go through E, we don't have an E yet, so create a new text link, push the E onto H's transitions, and then set E as the last text link. And it's just going to go over and over again. And then at the end, because we had just a kind of bit of hand waving, we created a dummy text head, which that one was going to be the first last link. So it's going to get given what was really the head, really the T here of the text input, and then from there you're going to be able, and then from there, so we just pop that off and pick next, so which there's only one option, and so that way we get the real text head, we get what is actually the T link there. Then from there we get the last link, which was the last link to run through here, in which case would be T again, and we say T, push T onto your transitions, which, for example, if we had testing for the win, there was an exclamation mark at the end, it would say exclamation mark, add T to your transitions. In that case, we don't have this little weird loop from character to the same character. And then from there, we hit return on the text head, which in this case would be the T. And so that's what gets returned there. Now, what are some of the... So as we're working through this, this means that, for example, since we have multiple T objects here, this is why T ends up with multiple paths that it might take. And that represents the different ways you might be able to move through this. In the same way, there are multiple elements that can move to T. So this is a short string. You get a very sparse distribution, and you'll notice that the shorter the strings, typically the more repetitions there are, or if there isn't very much variety in the strings, you'll get very little repetition, so you'll get the same thing repeated quite regularly. But as the strings get wider, they get a more diverse distribution of values. But if you have commonly repeating letters, you'll see those letters appear more in the text that's generated for the sketch. So Why is that so? Because those letters that exist in more often are in more transitions that might appear multiple times in the transition lists for different text links. Now, another way, so the problem with this, obviously, is as the text grows that you're putting into this function, the longer and longer your transitions arrays gets. So if you were to write this for dealing with a large book, that could be a problem. In that case, you would probably model transitions as their own object, and have this is the thing it references, and this is the probability, the weighting of landing on that. So that way you only need one that way you represent all the possible you represent the likelihood of landing on that transition. So that's kind of the next step up. In this case, you're just in a naive version because it's shorter, and we didn't need to. It would be an over-optimization of what we were doing because we're not trying to handle an entire book. So hopefully that gives you some idea as to what's going on in this text generator. If you're curious, if you've got other questions, hit me up on Slack. But I hope you guys had a great time in the tutorial, and look forward to seeing some of your creations for assignment 5. Adios.